Welcome to qnawire.
For case A, we apply Newton's law in a horizontal direction. That is, the sum of forces in x-axis direction is equal to mass times acceleration in x-axis direction. From here, force Fa plus force B is equal to ma plus mb, mass of A and B, times acceleration ax. Then we substitute the values, so 30 plus 30 times 10 to the power 3, this is 3, is equal to 25 plus 20 times 10 to the power 3 times acceleration ax. We solve for ax. This gives us 1.3333 meter per second squared. Now we use a Newton equation of motion to calculate the distance traveled by a train before it comes to stop. That is, v square is equal to v naught square plus 2a x minus x naught, where v is equal to 0, so this will be 0. 90 times 1000 divided by 3600, converting into standard units, which is meter per second, times the square, so this square is all over here, plus 2 into acceleration, which we just found, so that will be in a minus 1.3333 times x. We solve for x, and x we get here is 234.3821 meter. So this is the distance traveled by a train before it comes to stop. Then for case B, which is a car A only. So for B, car A only, we apply again Newton's second law, that is a sum of forces in Fx and x-axis direction is equal to mass times acceleration ax. Then we write the forces for Fa plus P is equal to ma times acceleration ax. Fa is equal to 10 to the power 3, this times 30, plus P is equal to 25 times 10 to the power 3 times acceleration that we found earlier, that is 1.3333. From here, this gives us P to be 3332.5 Newton.